Hello, my project is a machine learning and computer vision enabled robot arm for efficient garbage recycling. It's estimated that by 2050, 33 billion tons of plastic waste will be on the earth, overshadowing the Empire State Building by over 100,000 times. Not resorting to the recycling process can result in adverse environmental consequences. When materials such as paper, plastic, glass, and metal are not recycled, they end up in landfills, not only occupying space but also contributing to environmental pollution. Additionally, the production of new materials incurs energy consumption, deforestation, habitat destruction, and greenhouse gas emissions. Recycling helps conserve natural resources, reduce pollution, and lower energy consumption, making it inevitable for environmental sustainability. Current methods to recycle garbage include manual sorting, which is inaccurate, having an average accuracy of 88%. It often results in high contamination rates, and landfills and factories often have high concentrations of airborne dust, bacteria, and fungal spores, which can lead to cardiac and pulmonary diseases such as lung cancer. There's also some robotic recycling systems, such as the AMP Cortex DRS. This costs about 300K per unit. It has a 95% accuracy, but it's too expensive for it to be affordable and used at a larger scale. Another system is the UR5 robot arm. This costs about $35,000 per unit. It's used frequently for recycling garbage in the factory setting, but it doesn't come pre-coded with any garbage sorting capabilities, meaning it can be only used by an expert in the field. To produce a low-cost, easy-to-use robotic arm system that uses machine learning and computer vision to recycle and sort garbage, the following engineering goals were aimed for. First, use a webcam to send live video stream to ROS1. ROS, or Robot Operating System, is a set of software libraries and tools that helps you build robot applications. Then, using OpenCV, make a custom-trained YOLO v7 machine learning model to detect any recyclable objects in the webcam video stream. Send the locations of a recyclable object to the motion planner and ROS, and then calculate the robot movements needed to get to that location. Have the robot arm go to these coordinates, pick up the recyclable object, and place it in a recycling bin. Then train the robot to recognize recyclable objects at indoor and outdoor environments. And then lastly, make this robot arm cost effective. So first, I designed the robot arm in Fusion 360. I used an open source called Arctos for the base, and I edited that to fit my needs. And then I 3D printed all the pieces out. I painted them, installed the motors and the magnets, and after that, I assembled the robot arm. Next, I did the electrical construction. So first, I wired the circuit according to Figure 1, and then I placed the circuit in a wooden enclosure with 3D printed plates. Next, I made the custom-trained YOLO v7 machine learning model. I started off by cloning the YOLO v7 official repository from GitHub in VS Code. Then I gathered all my data, so I set the whole system up, placed a recyclable object in front of the robot, and I placed my camera where the webcam would be. And I took about 500 images per class. And after that, I used RoboFlow. Using data augmentation, I got about 1,500 images per class. Then I annotated all the data based on class in MakeSense.ai. Next, I trained the custom model for 500 epochs. And then I created a ROS package in using Moveit, which is a software tool that creates inverse kinematics equations for you. I made a real-time motion plugin node, which allows me to do real-time planning for the robot movement. And then I did the hardware interface using ROS Serial, a communication protocol that allows ROS to connect with any microcontroller. I made a node in Arduino IDE, which receives the real-time planning from Moveit and moves the motors accordingly. Then I did the robot calibration, which ensures that the robot's moving accurately. Next, I integrated the machine learning model with ROS. So I created an OpenCV node that takes in the camera stream from the webcam, detects any recyclable objects, and if there are any, it sends their locations to ROS. And finally, I made a pick and place node, which receives the location of a recyclable object from the OpenCV node, sends those locations to the motion planner in Moveit, and then once Moveit figures out what the robot needs to do to get to that location, it sends it to Arduino IDE through ROS Serial. and the robot will move accordingly, resulting in the robot picking up the recyclable object and placing it in the recycling bin. In Figure 2 and 3, the fully constructed system can be seen. Figure 4 is the machine learning model detecting garbage from a webcam. In Figure 5, the real-time planning and move it can be seen. A video of the robot arm system successfully identifying garbage can be seen here. 3 pieces of garbage were placed in front of the robot arm. The middle one, the soda can being recyclable. The system uses a webcam to correctly identify that the soda can is recyclable. Then it sends the location of this object through the OpenCV node. You can see in the middle the location being sent to the Move It interface, and then Move It makes a box at the location of the recyclable object, as you can see here. Then it plans on how to pick it up and place it in the recycling bin. And it sends this to the Arduino Mega over raw serial, and the Arduino Mega executes this through the motors. So the overall accuracy of the robot was 98% over 100 trials. 50 of these trials were done inside and 50 outside. The robot operates autonomously without any human assistance. The user can easily adjust the robot's speed, the rate of recycling. The user can also adjust where the robot should place the garbage, so the location of the recycling bin. The robot's 3D printed, meaning the parts can be easily upgraded or repaired. The system size can be scaled. The gripper can be customized to fit a specific cause. The user can easily replace parts if they get damaged. The total cost of the system was about $274, which is much cheaper than any other options on the market, such as the AMP Cortex DRS and the UR5 robot arm. The system is still a prototype, meaning it has some limitations, such as it's dependent on electricity. It requires a running computer, and the robot arm is not wireless, meaning it requires a cable connection to a computer. Some future improvements could be the robot arm could be powered by solar energy. A mobile application for controlling the robot arm can be made using RPST, so network signals. An ESP microcontroller, a low-cost microcontroller with integrated Wi-Fi and Bluetooth can be used to make the robot arm wireless. All engineering goals were met. The system is highly cost efficient, costing a total of about $274. It showed an accuracy of 98% over 100 tests. It can be used by anyone and can be used by anywhere, and due to this being 3D printed, it can be easily reproduced at very large scales. And in a world where landfills are quickly filling up and current methods are having a hard time keeping up, this innovation holds the potential to quickly increase recycling rates and make garbage easy to recycle. Thank you.